So we've talked about how the internet satisfies the goals of sharing and interconnection. And now let's talk about some of the other goals that are discussed in the DARPA design philosophy paper. As we discuss some of these other goals, it's worth considering and thinking about how well the current internet satisfies these other design goals in the face of evolving applications, threats, and other challenges. One of the goals discussed is survivability, which states that the network should continue to work even if some devices fail or compromised, and so forth. There are two ways to achieve survivability. One is to replicate, so one could keep state at multiple places in the network, such that when any node crashes, there's always a replica or hot standby waiting to take over for the failure. Another way to design the network for survivability is to incorporate a concept called fate sharing. Fate sharing says that it's acceptable to lose state information for some entity if that entity itself is lost. For example, if a router crashes, all of the state on the router, such as the routing tables, are lost. If we can design the network to sustain these types of failures, where the state of a particular device shares the fate of the device itself, then we can withstand failures better. So fate sharing makes it easier to withstand complex failure scenarios, and engineering is also easier. Now it's worth asking whether the current internet still satisfies the principle of fate sharing. In a subsequent lesson, we'll talk about network address translation and how it violates the notion of fate sharing. There are other examples where the current internet's design violates fate sharing, and it's worth thinking about those.